Hello, students. This is Mr. Green. I am filming this from my home this time because the governor has recommended that we all try and stay in our houses as much as possible. And so I'm here at my house filming this today. You can maybe see my hand here. Hello. Maybe uh, if I get my room a little bit more cleaned up here, I can actually have you see my face. Um, but for the time being, I'm just going to be showing you these beautiful whiteboards. And so hopefully you're all doing well, taking care. It's so crazy, everything that's going on. We are going to start into the Chapter 6 material today, which is about matrices, which I find super fun and very, very exciting. Hopefully you will too. So what I'm going to do first off is just show you kind of why we use matrices and what they're really good for. In Chapter 5, we had been doing things of solving systems of equations, right? Things like if you had an equation like this, 2x minus y equals 5, and another equation, x plus 4y is equal to 7, okay? This is a system of equations, right? And it has, well, hopefully it has a solution. It might not, right? But I think it does for this one. And how we had found this previously was we had used either substitution or elimination to solve for this. In this case, well, either one would be fine. Yeah. So essentially what we want to do here is, if you noticed when we were solving a system of equations, there was kind of a lot of repetition in writing x's and y's all the time, right? Sometimes, especially in the nonlinear equations, this is linear because it only has powers of 1 on the x's and y's, okay? For nonlinear things, it was really important to write the variables, but really for a linear equation where we just have a number times x and then a number times y equals some other number, and then a number times x and a number times y equals some other number, it really becomes kind of repetitive to have to write x and y so much. And so what we are going to do is we're going to look at what are called matrices, which is essentially just a way of condensing this down into a really nice form. Okay, and so essentially what a matrix is I would just get rid of the x's. I do a little bracket here, okay, bracket on both, and I just put in the coefficients on the x's and the y's. So the coefficient on this one is 2, so I'm going to put a 2 there. The coefficient on the y is -1, and then 5 is what it equals to, so I'm going to put 5. Okay, so this is, I just kind of put a row of numbers where the numbers are the coefficients that I'm dealing with in these equations. Okay, I do the same thing here. There's a 1 in front of the x, so I'm going to put a 1 right here. There's a 4 in front of the y, so I'm going to put a 4 here. And there's a 7 on the other side, so I'm going to put a 7 there. Okay, so this is a matrix. Matrix. Whoa, hopefully you can see that. This is what's called a matrix. It's just kind of rows and columns of numbers, okay? Now, normally those rows and columns of numbers mean something. They're not just random numbers. Like in this case, they're the coefficients in this system of equations, which could come from a story problem. but this is just kind of a way of representing the system of equations without having to use any variables, okay? So this is a matrix, and specifically we call this where it represents a system of equations here, we call it an augmented matrix. Because it represents a linear system of equations. Okay, so it represents a system of linear equations, and so we call this an augmented matrix. Okay, so hopefully that kind of helps. I think you've seen matrices before, hopefully, and hopefully this will kind of, our lesson today will kind of be a refresher on what matrices are good for and why we care about them so much. Essentially, in future videos, we're going to see that we can do the same sort of elimination process that we did for regular systems of equations, just using this matrix here, okay, so that we don't have to write x's and y's so much. As well, something I should mention here is that a matrix has dimensions, okay? So the dimensions of this matrix are, it has 2 rows, right? 2 rows this way, and 3 columns. 1, 2, 3. So we call this a 2 by 3. These are its dimensions. Okay, it has 2 rows and 3 columns. Or as my linear algebra teacher would say it, he would say rows and columns because he was Austrian. Anyway, so initially whenever I say rows, I tend to just gravitate towards saying columns for columns. So if I accidentally say that, just you'll know I'm meaning columns instead of columns. Anyway, okay, so I do want to do one example before we move on to the next video, and you'll actually be able to do a few homework problems just from this really basic introduction. I want to write, I'm going to do an example over here, example. Write the augmented matrix for the system. Okay, I've got a system of equations here. And my system is 3x minus 2y plus z is equal to 5. And then my other equations are x plus 3y minus z is equal to 0. And then negative x plus 4z is equal to 11. Okay? And maybe I should, I'm going to rewrite this so that it's closer to the other z's. Okay, plus 4z. Okay, so I just made it so all my z's were lining up in this equation. And they normally will do that in the book as well. So, what we have here is a system of equations with 3 variables, okay? And I want to write the augmented matrix for this system. So essentially what I just need to do is I need to take the coefficients on front of the variables and throw them into a matrix. So I do put my brackets for my matrix, and then my first coefficient for x is 3, so there's going to be a 3 in the first row in the first spot. Then the coefficient on y is -2. The coefficient on z is +1. And then the thing on the other side of the equal sign is 5. Okay? Then I've got x, so coefficient in front of that is 1. Coefficient in front of 3y is 3. Coefficient in front of -z is -1. And then 0. Okay? So I'm just throwing the numbers into the matrix. Okay? Now, number in front of x is -1 there. Now, you'll notice here there isn't any y's in here, right? So the coefficient in front of y would just be 0 because there's no y's. Okay, so I would put a 0 down here in the matrix for y. Okay, and then 4z, so 4, and then 11. Okay, so this is my augmented matrix for this system. Okay, and just to kind of remind ourselves, what would the dimension of this matrix, what would they be? Well, it has 3 rows and 4 columns, or columns. Okay, so it's a 3×4 matrix. Okay, so hopefully that helps. You should be able to do a few homework problems now. I look forward to seeing you in the next video, and we'll do some more fun things with matrices.